Hello everyone. In this video, we are going to solve the problem number 1.71 from Irodov, and that is related to dynamics. So let us first understand the problem and then we will solve the problem step by step. So we are having a pulley fixed to the ceiling of an elevator car which carries a thread whose ends are attached with the mass m1 and m2, and assuming the masses of the pulley and the thread are negligible and there is no friction between the pulley and the thread, and we have to find out the acceleration of load m1 relative to the elevator shaft and the relative to the car, and we also have to find the force exerted by the pulley onto the ceiling. Now let us first understand what is the meaning of elevator shaft, elevator car. So let us say we are having a building in which the elevator is moving from the ground floor to the topmost floor, and it is moving with the help of the guide rail. So let us say these are the rails that I have drawn which is attached to the building. These rails are attached to the building, and on this particular rails we are having the elevator car which is moving from one floor to the another floor. So basically these two rails, that is called the elevator shaft elevator shaft and it is attached to the building. So basically if we are talking about relative to the elevator shaft, that means we have to find out the acceleration in the ground frame of reference. And if we talk about relative to car, so basically relative to the elevator car which can move with some acceleration a, and then it is the non-inertial frame of reference. So let us first talk about the acceleration of load m1 with respect to the elevator car. So let us say we are having the observer which is sitting inside this elevator. So if it is sitting inside the elevator, that means this particular observer is the non-inertial frame of reference. And we know that if we are having the non-inertial frame of reference, in that case we cannot directly apply the Newton's second law of motion. For that we have to use the pseudo force, and that we have to apply in the opposite direction of the acceleration of the non-inertial frame of reference. So we are having the acceleration of the elevator is w naught and it is in this particular direction. Then if we draw the free body diagram of mass m1, let us say this is mass m1, then we will have the gravitational force in the downward direction, that is m2 into g, and we will have the pseudo force, that is m1 into w naught, that is in this particular direction which is opposite to the direction of the acceleration of the elevator car, and we will have the tension force in this particular direction. Let us say the acceleration of mass m1 with respect to the elevator car is equal to w1, let us say, or we can say w dash. Okay, then this particular mass m1 will move in the upward direction with the acceleration of w dash. So if we write the force equation in this direction, that we can write it as T minus m1g minus m1 into w naught is equal to m1 into acceleration is w dash. Now let us draw the free body diagram of mass m2. So this is mass m2, and we will have the tension force in the upward direction and the gravitational force m2g in the downward direction, and m2 into w naught in the downward direction, as we are having the acceleration of the elevator car in the upward direction, and it is moving in this particular direction with the acceleration of w dash. As in the frame of reference of this elevator car, this particular thing, the pulley will be in the rest condition, and if it is pulley is in the rest condition, then the acceleration of mass m1 and mass m2 will be same, but it will be in the opposite direction. So that's why the acceleration of mass m1 is in this particular direction with the acceleration of w dash, and acceleration of mass m2 is in this direction with the acceleration of w dash. Now if we balance the forces, then we can write m2g plus m2 into w naught minus t is equal to m2 into w dash. So using these two equations, we can find the tension force and the acceleration. So we can add equation 1 and 2. This is equation 1 and equation 2. So we can add 1 and 2. So we will get m2 minus m1 into g plus m2 minus m1 into w naught is equal to m1 plus m2 into w dash. Okay. So from here we can get w dash is equal to m2 minus m1 as common. So we will get g plus w naught whole divided by m1 plus m2. So this is the acceleration of mass m1 we got, which is in the upward direction. Okay. Now from here we can find out the tension force by using, let us say, first equation. So we can say T minus m1g minus m1 into w naught is equal to m1 into w dash. So from here we can write T is equal to m1g plus m1 into w naught plus m1 into m2 minus m1 times g plus w naught whole divided by m1 plus m2. So let us expand it. Then we can write m1 times m1 plus m2 into g plus m1 times m1 plus m2 into w naught plus m1 times m2 minus m1 into g plus m1 times m2 minus m1 into w naught whole divided by m1 plus m2. So from here we can write tension force is equal to m1 square g plus m1 m2 g plus m1 square into w naught plus m1 m2 into w naught plus m1 m2 into g minus m1 square into g plus m1 m2 into w naught minus m1 square into w naught whole divided by m1 plus m2. So from here this m1 square g will get cancelled, and m1 square w naught will get cancelled, and we can write tension force is equal to 2m1 m2 times g plus w naught whole divided by m1 plus m2. So this is the expression of tension force we got in this particular thread, but we have to find out the force exerted by the thread onto the ceiling. So if this particular tension force is T, this particular tension force is T, then this tension force will be 2T. So we can write the force exerted by the ceiling, force exerted by the ceiling is equal to 2T, and that we can write it as 4m1 m2 times g plus w naught whole divided by m1 plus m2. So this is the expression of the force we got, that is exerted by the ceiling on the thread or by the thread on the ceiling. Now let us talk about the ground frame of reference. Ground frame of reference. And what is the acceleration of body 1? That we can write it as acceleration of body 1 with respect to the car or the elevator plus acceleration of the car. Acceleration of body 1 with respect to car, that we have found out, that is w dash. So we can write w dash plus, and acceleration of the car is given as w naught, so that is w1. So this is the acceleration of the body m1 with respect to ground. So from here we can write w1 is equal to w dash, we have found out that is m2 minus m1 into g plus w naught. So m2 minus m1 into g plus w naught whole divided by m1 plus m2 plus w naught. So from here we can write m2 minus m1 into g plus m2 into w naught minus m1 into w naught plus m1 w naught plus m2 w naught whole divided by m1 plus m2. So here this m1 w naught will get cancelled, and finally we will get w1 is equal to m2 minus m1 into g plus 2 times m2 into w naught whole divided by m1 plus m2. So this is the expression of acceleration we got in the ground frame of reference or with respect to the elevator shaft. Now this is the acceleration we got. So if we draw the free body diagram of mass m1, so in this particular direction we will have the gravitational force, that is m1 into g. Now we are talking about the inertial frame of reference, that is ground frame of reference. That's why we will not have any pseudo force, and we will have the tension force in the upward direction. So we can write T minus m1g, and as it is moving in the upward direction with the acceleration of w1, so we can write is equal to m1 into w1. So we can write tension force is equal to m1g plus m1 times w1 is m2 minus m1 into g plus 2 times m2 w naught whole divided by m1 plus m2. So let us expand this particular expression. So we will get m1 square g plus m1 m2 into g plus m1 m2 into g minus m1 square into g plus 2 m1 m2 into w naught whole divided by m1 plus m2. Here this m1 square g will get cancelled, and we will get the tension force as 2 m1 m2 times g plus w naught whole divided by m1 plus m2, and the sealing force we can write it as 2t is equal to 4 m1 m2 times g plus w naught whole divided by m1 plus m2. Okay, so this is the tension force which is same as what we got here. That means the tension force is not changing in any reference of frame. Okay, only the acceleration will change in if we choose the different frame of references. So here if we see in the book, it is given that if we talk about the acceleration, then acceleration is given as g minus w naught. So basically in the solution it is given as the vector quantity, but I have considered it as the actual value of the acceleration, and this is the magnitude of the acceleration is what showing. I hope the entire procedure is clear. Thank you.